This is the unit on evaluating syllogisms. In the last unit, we learned what syllogisms are and how to identify them, and we saw the standard form of expressing syllogisms. Here we're going to learn a systematic method for evaluating syllogisms. So back to the rules again. For a syllogism to be valid, it must follow all four of these rules. First, there must be at least one affirmative premise. Second, if there is a negative premise, the conclusion must be negative. And if the conclusion is negative, there must be a negative premise. 3, the middle term must be distributed at least once. And 4, whatever is distributed in the conclusion must be distributed in the premises. Okay, let's go on to some examples, and we'll apply the rules and see how they work in practice, and inshallah be able to understand them more clearly that way. All right, here is a syllogism. All sensitive persons are dreamers. All dreamers are poets, so all sensitive persons are poets. First, let's look at what the form of that syllogism is. So if we put it in standard form, we replace each term with a letter, which is a variable representing that term. So we have a subject term and a predicate term, and we also have a middle term. So remember, the middle term is the term which is not in the conclusion, right? So we're going to assign S for subject to the subject term in the conclusion, and P for predicate to the predicate term in the conclusion, right? And the middle term will be assigned the letter M. Okay, so here we have an argument of this form: all S is M, all M is P, and therefore all S is P. So the first rule of the 4 rules, remember, and if you had written down these rules, it would be a good idea. If you have them in front of you, you can refer to them. Then soon you will have them by memory, and then when you take the exam, or when you're just in life, at the real exam, right, in real life, the real test of your thinking, you'll have them in mind, and you can see when somebody's trying to pull a fallacious argument over you that looks like a valid one, because you'll have a tool that you can use to distinguish the true from the fake logic, right? But have those rules in front of you, and we'll apply them in order. So the first rule was that there must be an affirmative premise. There must be at least one affirmative premise. Here you can see both premises are affirmative, right? All sensitive persons are dreamers. Yeah, all dreamers are poets. Okay? Recall the 4 types. If it's negative, it would say either no sensitive persons are dreamers, or some sensitive persons are not dreamers, right? Both of these are affirmative, so that rule passes. The second rule was, if there is a negative premise, the conclusion must be negative. And if there is a negative conclusion, one of the premises, at least one of the premises, must be negative. Here, both premises are affirmative and the conclusion is affirmative, so the rule passes, right? Okay, so think about what the rule says carefully. It doesn't say that there needs to be a negative premise or a negative conclusion. It says if there is a negative premise, the conclusion must be negative. And if the conclusion is negative, at least one of the premises must be negative, right? So that when you test the argument with that rule, the first thing you'll do is you'll look and you'll ask, is there a negative premise, or is the conclusion negative? If the answer is no, because they're all affirmative, then it passes the rule, right? If the answer is yes, and there is a negative premise, then you have to look to check and see if the conclusion is negative. And if the conclusion is negative, then it passes that rule. But if the conclusion is not negative, that's to say, if it has a negative premise but an affirmative conclusion, it will not pass, right? Or likewise, if it has a negative conclusion but no negative premise, it will not pass. Okay, but this one passes because everything here is affirmative. So, the rule doesn't actually apply here. Okay, so the third rule was that the middle term must be distributed at least once. Here, the middle term is dreamers. Now we've made it easy because we put it in red, right? Dreamers. And so we have to ask, is the middle term distributed here? Well, in the first premise, right, dreamers is the predicate, right, term. And we saw that in our chart there, if the proposition is of the form all S is P, the S term is distributed, but the predicate term is not distributed, right? So that means that here, where it says all sensitive persons are dreamers, dreamers is not distributed. So the middle term is not distributed in the first proposition. But in the second proposition, the middle term is in the S position. Dreamers is in the subject position, right? So if we go back to our chart, we find again in the proposition of the form all S is P, S is distributed, but P is not. And so here in this premise, dreamers, the middle term is distributed. And so therefore, this passes rule 3. That again was the rule that the middle term must be distributed at least once. And we have found that the middle term is distributed in the second premise here. Okay. Now, the fourth rule was that whatever is distributed in the conclusion must be distributed in the premise, right? In the premises. So the conclusion here is that all sensitive persons are poets. So what we have to ask ourselves is anything in this conclusion distributed? Because if it is, it also has to be distributed in the premises according to the rule. Well, again, the proposition of the form all S is P, S is distributed, but P is not. Here, sensitive persons is the term that's in the S position, in the subject position. And so sensitive persons is distributed in the conclusion. That means that sensitive persons must be distributed in the premises, according to the fourth rule. And if we look up in the premises, we find sensitive persons in the first premise. And in that premise, again, it's the form all S is P. Sensitive persons is in the S position, which means it's distributed in that premise. And so it passes rule 4, because sensitive persons being distributed in the conclusion is also distributed in the premises. And so that tells us that this one is valid. Okay. So that seemed like a long process, and we went through it, rather slowly and meticulously because I want you to understand each rule. But I don't think that it should be a process that takes you that long, because it's not really that difficult or complicated. Once you remember the 4 rules and the concepts of distribution in the middle term, it should go by fairly quickly. Okay, so we're going to do another one, and we'll try to see if we can do it a little bit faster. Yeah. Oh, but look at this. This is a strange one. What are these terms? All goo-goo is gaga. All gaga is coochie. So all goo-goo is coochie. Well, these terms have no meaning, right? And so none of these propositions can really be meaningfully true. But why did I put this here in this way? Because I want to emphasize the fact that we are looking at the formal structure of the argument. We're examining the formal structure of the argument. So we can determine the validity or invalidity of the syllogism even when the terms involved are complete nonsense terms, right? Right, okay. Because what matters is the form, right? For this purpose, right? When we want to know whether the argument is sound or not, we need to know whether the premises are true and whether we have good reason to believe that they're true we need to know what the premises mean. And so that, of course, is crucial. I mean, we can't really apply this to reality without that. But we're specifically focusing on the formal element in this case, and that separately, so that we can worry about how to determine the truth of the premises in a later context, a different context, right? And that all depends on what the premises are about, right? So, okay. Right. This is of the form, all S is M, all M is P, and all S is P. That's the form of this argument, right? Once we sort of abstract from the nonsense content here, right? And what I want you to notice now is that this is the exact same form as the previous argument, right? So let's go backwards. See, that one, which we already said was valid, is of the form all S is M, all M is P, so all S is P. So if we go back to this one, we find the form, right? We see this is the same form. All Gugu is Gaga, right? All S is M. All Gaga is Coochie, right? Gaga comes up again, but in the right first position. All M is P. So all S is P. So if the last argument was valid, and this argument has the same form as the last one, this one's valid too, because validity has to do with the form and not the content, right? So we can just quickly know that this one's valid, right? It passes the rules because we basically already tested it. We tested it in the last one, okay? All right. And this is valid. All right, so now let's look at one with a different form. Some sensitive persons are dreamers. All dreamers are poets. So all sensitive persons are poets. Yeah. So what's the form there? Some sensitive persons are dreamers. That gives us a proposition like that. Some S is M. All dreamers are poets. All M is P. So all sensitive persons are poets. All right. So let's apply again our 4 rules. The first rule is that there must be one affirmative premise. Both of these premises are affirmative, so it passes. The second rule, again, was that the middle term must be distributed at least once. The middle term here is dreamers, and it is distributed in the second premise. All dreamers are poets, right? That is telling us something about every member of the category dreamer, telling us something about all the dreamers, so it's distributed. I'm sorry, that was the third rule. So that was the rule that says the middle term must be distributed at least once. Okay, now for a different sort. Some sensitive persons are dreamers. All dreamers are poets. So all sensitive persons are poets. And we see that the form of this is different. Some S is M. All M is P. So all S is P. Okay. So we'll have to apply our rules again, because we can't just go by comparison for the previous one, since this is a different form from the previous one. Our first rule, again, is that at least one premise must be affirmative. And we see both of the premises here are affirmative, so it passes that rule. The second rule was that if there's a negative premise, then the conclusion must be negative. And if the conclusion is negative, then at least one premise must be negative. But the premises are both affirmative and the conclusion is affirmative, so that passes that rule. The third rule, again, was that the middle term must be distributed at least once. The middle term here is dreamers, and we can see that in the second premise, dreamers is distributed, right? Since it is in the position of S in the all S is P form of categorical proposition. And if we look at the chart, in that form of proposition, S is distributed. So dreamers is distributed here. And then the fourth rule was that whatever is distributed in the conclusion must be distributed in the premise. So the conclusion here is of the form all S is P, and so S is distributed, right, in this conclusion, because in the form of proposition that all S is P, in a proposition of the form all S is P, S is distributed. So sensitive persons is distributed here. But if we go back and look in the premises, we find sensitive persons only appears in the first premise. And that first premise of the form some S is M, some sensitive persons are dreamers, is not telling us anything about all the sensitive persons, just some of them. And so in that premise, sensitive persons is not distributed. And so this argument fails to meet the fourth rule, which is that whatever is distributed in the conclusion must be distributed in the premises, because sensitive persons is distributed in the conclusion here, but it's not distributed in the premises, right? So it's invalid, because the term distributed in the conclusion, but not in the premises. All right. Okay, here's another one. All statesmen are honorable persons. Some honorable persons are politicians. So some statesmen are politicians. And that has the form all S is M, some M is P, so some S is P. Right. Now it has an affirmative premise, so it passes the first rule. There is no negative premise, and the conclusion is not negative, so that rule doesn't apply. Goes through there. Now the other rule, the third rule, is that the middle term must be distributed at least once. Well, the middle term here appears in the first premise, all S is M, right? All statesmen are honorable persons. And honorable persons, which is the middle term, is not distributed in that premise. And in the second premise, it appears in this other form of proposition, some M is P. And, if you look at your chart again, and I think by now you should know this offhand, the middle term, the term M is not distributed in that proposition either. And so the middle term is not distributed in the premises here at all, in neither of the premises. And the rule says that the middle term must be distributed in at least one of the premises. And so this argument fails to meet that rule, and so it's invalid because of an undistributed middle term. Okay? All right, here's another one. No intelligent persons are gluttons. Some famous people are gluttons, so some famous persons are not intelligent. The first rule, again, there must be at least one affirmative premise, and we find that in the second one here. The second premise, some famous people are gluttons, is an affirmative premise. The second rule was that if there is a negative premise, then the conclusion must be negative. And if there's a negative conclusion, there must be a negative premise. We see there is a negative premise. No intelligent persons are gluttons. And we're good to go because the conclusion is also negative. Some famous persons are not intelligent. The fourth rule said that whatever is distributed in the conclusion must be distributed in the premise. So here we find that the proposition is that some P is not S. If we go back to our distribution chart, recall in the proposition of the form some P is not S, the S is distributed. And therefore S must be distributed in the premises, right? In other words, here the term intelligent is distributed in the conclusion, and therefore the term intelligent must be distributed in the premises somewhere. And that is the case in the first premise, right? Because the first premise is of the form no S is M, and remember in that kind of proposition, both terms are distributed, both the S and the P, right? So intelligent is distributed in the premise, and therefore it passes the rule. Again, the rule was whatever is distributed in the conclusion must be distributed in the premise. Intelligent is distributed in the conclusion here, and it's also distributed in the premise. So the argument passes all the four rules and it's valid. Okay. All right, here's another one. All gluttons are unintelligent. Some famous people are gluttons, so some famous people are unintelligent. All M is P, some S is M, therefore some S is P. All right, the first rule again is that there must be an affirmative premise, and there is. All gluttons are unintelligent, right? The second rule is that the middle term must be distributed at least once, and the middle term is gluttons. We find it's distributed in the first premise of the form all S is P. So remember, in that kind of proposition, S is distributed, but not P. Okay, so gluttons is distributed in the premises, so that's good to go. The other rule was that if there is a negative premise, there must be a negative conclusion. And if the conclusion is negative, there must be a negative premise. And it looks like the premises are both affirmative as well as the conclusion. So that is something we pass, right? The fourth rule was that whatever is distributed in the conclusion must be distributed in the premises. And nothing is distributed in the conclusion, actually. Some famous persons are unintelligent. And that means that, neither of those need to be distributed in the premises. So this passes all four rules and it's valid. Okay? All right. No intelligent persons are gluttons. Some famous people are not gluttons. Some famous persons are intelligent. I should have put persons instead of people. So persons, people, we mean the same thing there. So let's say this. No intelligent persons are gluttons. Some famous persons are not gluttons. Some famous persons are intelligent. No S is M. Some P is M. Some P is S. Okay. So it says that there must be an affirmative premise. That's the first rule. And here we have two negative premises. There's not an affirmative premise. So this one fails right away, breaks the first rule, no affirmative premise. Some animals are furry, some furry things are cats. So some animals are cats, right? There is an affirmative premise. Some animals are furry, right? Both of them are affirmative. And there's no negative premise or negative conclusion, so we didn't worry about that rule. It passes that rule. Now the third rule was that the middle term must be distributed at least once, right? It looks like the middle term is not distributed because we have two propositions that are merely existential, right? Some S is M, some M are P. Remember, in a proposition of that form, neither term is distributed. So the middle term can't be distributed anywhere there. It's undistributed in both cases. And so this fails by breaking the rule that the middle term must be distributed at least once. So this is invalid for reason of an undistributed middle term. Okay. All cats are furry. Some animals are cats, so some animals are not furry. All M is P, some S are M, so some S are not P. Well, we can immediately see what's wrong with this one, I think by now, because we should be used to the four rules. And the problem here is that the conclusion is negative, some S are not P, but there's no negative premise. So remember that rule was that if the conclusion is negative, there must be at least one negative premise. Or if one of the premises are negative, then the conclusion must be negative. Here we have a negative conclusion, but no negative premise, so it breaks that rule. Right? It's invalid for the reason of having a negative conclusion with no negative premise. All cats are furry. Some animals are not cats, so some animals are furry. All right, we have an affirmative premise. All cats are furry. We have a negative premise, right? Some animals are not cats. And remember the rule said, right, that if a premise is negative, then the conclusion must be negative. But this looks like I messed up this one because I have a different form. The form that I have down here is wrong. So if you caught that, that should be an educational experience. Sometimes your teacher's mistakes are educational. Yeah. So this should be that some S are not M and then some S are P, right? Anyway, the problem here is that we have a negative premise, but we don't have a negative conclusion, right? So that should be invalid. Negative premise with an affirmative conclusion. Yeah. Okay. And that's all for our section, our unit on evaluating syllogisms. What you need to do is make your own little distribution chart and make yourself a list of the 4 rules until you kind of have them memorized, and engage in the exercises that are available on your own, and practice being able to see the valid inferences from the invalid ones, right? Being able to distinguish the valid syllogisms from the invalid syllogisms as quick as you can, right? When these rules, these simple rules are ingrained in your mind and habit of thinking, you'll be able to see when you are encountering an inference of this type, a syllogistic inference, you'll be able to judge its validity quickly and more or less reliably, right? Now, even though nobody will be ever perfect in that, but the more practice you have, the more you'll be able to distinguish when confronted with this sort of inference, the logical ones from the fallacies, and you'll be that much intellectually stronger for it. All right, go and enjoy your exercises.